Hello, wonderful chem students. In this video lesson, I'm just going to be explaining what our burning down the house project is. So first thing that you need to know about this project, the main purpose of this is that you are going to mix kind of that classic vinegar and baking soda. When those mix, one of the things they produce is carbon dioxide. And carbon dioxide will extinguish a candle. So ultimately what you are going to end up doing is you are going to have a house that would have 3 different rooms in it. So with those 3 rooms, you're also going to have a 2-liter where you're going to mix in some later calculated amount of vinegar and baking soda. Then what those are going to do is you're going to have to calculate exactly the volume of your vessel, as we'll call it. So like a 2-liter or a pop bottle, it's your choice. So your vessel of the straws that are leading in, and then your rooms, which are going to have 3 lit candles. And the purpose of this lab is for you to calculate, right, because we're learning about gases, exactly the volume of CO2 to be produced that will fill your vessel, fill your straws, and then also fill your rooms of your house that have a lit candle inside. And if you do those calculations correctly, that CO2 gas should then extinguish those 3 candles, because we know that candles need oxygen to breathe. So if it fills with CO2, the candles will go out. So your procedure, you need to ultimately end up building a house. You can get as creative or as lazy with this as you want. If you just want to use a shoebox and put some dividers in it, great, you can do that. If you want to build something fancy out of Legos, great, you can do that as well. It is completely your choice. But it must have 3 rooms. Each one will have a candle, no roof, open doors, windows, things like that. Yeah, you can get as complex with it as you want. So ultimately what you're going to be solving for is a volume of gas. Some information to know that is kind of like our room temperature, the data that we're going to use that's close enough. We're going to say our room temperature is 23 degrees. We're going to say 730 millimeters of mercury for our pressure. It's also important to notice that vinegar is 5% acetic acid. So of all of the vinegar that you use, if you use 20 milliliters, only 1 milliliter or 1 gram that is actually acetic acid. Density of vinegar is close to that for water, so we can basically say 1 gram is 1 milliliter. And then it says that baking soda, and it gives you the formula for that, and acetic acid also gives you that formula, react to produce carbon dioxide, sodium acetate, and water. Your extinguishing system must be self-sufficient, so straws, bottles, jugs, tubes may not be moved, squeezed, or whatever. So basically you get to pour in your vinegar, pour in your baking soda, and put the lid back onto whatever your device is. So if you have this pop bottle, realistically your straws are probably more so coming out the sides here, so that way you can still put the lid on. Because if you don't get a lid back on there, what's going to happen is a lot of your CO2 is going to escape out the top. You want to make sure that that CO2 is kind of forced out through your straws, and that way it can make its way into the houses. So it's important to note that this is an engineering project as well, right? That is some of our science standards is engineering, so design with constraint. So that is part of this as well. And then you can see kind of the rubric for what this lab will look like. So what I want to use this video to help you do is not only introduce the lab, but I'm actually going to help you with the practice calculations if you were not able to receive help from your teacher for whatever reason, whether it's absences or who knows. So then the other document that you should have access to would be this burning down the house mock calculations. So if we were to go through and do this, the way that I would start by doing this is, let's say that this was your reaction vessel, whether it was a 2-liter bottle or whatever. So it's important to note that the volume of a cylinder, whether we're talking your straws or tubing, or whether we're talking whatever your reaction vessel is. So that is going to be, the volume is equal to pi times the radius squared multiplied by the height. And it's important to note that you do have to do radius squared first. You just want to make sure that you're not accidentally squaring the pi in with it or something along those lines. So I'll go through and do some practice information. And we do have some data here for you as well. And then let's pretend that this was your 3-room house. Maybe you have one room is larger than the others for some reason. I don't know. It's your design. It's just to help you get practice. And then here's your other room. So each one of these would have a candle placed in it. Just to kind of keep the idea of the lab there. And then I'll help you how to solve for these. And then it's just important to note that the volume of a rectangle is always length times width times height. So now what I'll do is I'm going to pause here for a second just to collect my data, and I'm going to start to solve, do some of these practice calculations with you using the data from above. Okay, to do some practice calculations here, since it's probably one of the harder parts for students, specifically related to any of the cylinders, is let's pretend for a second that this was our diameter of whatever our vessel is. If you just have like a 2-liter, you can just use volume of a 2-liter, but let's say you use like a coffee can or something, then you would need to actually calculate that. So some things to note. One, if I measure the height and the diameter, it's just important to remember that the diameter is going to be that full distance across. Radius is only half. So what I had to do here is I took my diameter, simply divided it by 2, and I find that the radius would be 6.70 centimeters. So then following my equation, for volume of a cylinder, I took pi times 6.70 squared, multiplied by 20.3 centimeters, and I get 2,862.8 centimeters cubed. But I do need to follow my rules of sig figs here. And since I had a 3 sig fig value, 3 sig fig value, I do have to shorten this to be 3 sig figs as well. Similarly now is realistically, since we have 3 rooms, I should probably have 3 straws on this image. So pretend I have a 3rd straw here as well. So with that, same thing, if I measure the diameter of a straw or tube or whatever to be 9.5, following my rules of sig figs, that would be 4.8 centimeter radius. So I did the same thing down here, pi times 4.8 squared. Difference being now is I only had a 2 sig fig number due to measurements, which means when I multiply all this across, I have to shorten this to 2 sig fig number right here. Then what I need to be careful is that would actually only give me one of my tubes, but since I'm going to actually have 3 tubes, right, one probably running to each room, is let's just, in this case, I'm just going to assume they're all the same length. I would go ahead and I would actually need to multiply that 2,400 by 3. And I would find that the total volume coming from my tubing is 7,200 centimeters cubed, plus I had the 2,860 centimeters cubed coming from my vessel. So if I add those together, and it's important to remember that when we add sig figs, I can only go to my least precise place value. So in this case, I would get 10,060. Which my least precise place value is the hundreds. So I would actually end up rounding this to 10,100 centimeters cubed. So that's going to be the volume coming from just my vessel and my straws or my tubing. But then what I also have to do, and I'm going to pause here, is I need to find the volume of my house itself. So I need to find the volume of these 3 rooms. Okay, so now what I would have is I just pulled my information. Let's say I had those 2 smaller rooms. Maybe each of those smaller rooms was a height of 10 centimeters, length of 23.2, and a width of 7.8. So I just brought that information down here, length times width times height, and I find that the volume of one small room would be 1,809 centimeters cubed. I do need to be careful in this case, since I do have a 2 sig fig measurement in there. I need to shorten this to 2 sig figs, which is going to be 1,800 centimeters cubed, but then since I have 2 of those rooms, I'm going to end up with 3,600 centimeters cubed of that volume. For the larger room, 15 times 33.1 times 8.5. And similarly, I have a 2 sig fig answer. So if I shorten that down, I find 4,200 centimeters cubed. Now what I need to do is I can just add all of these together, right? I still had the volume of my vessel, the volume of my tubing. Now I just need to add in the volume of my house. So I can go ahead and add in the 3,600 as well as the 4,200. And if I do that, I get an answer of 17,900 900 centimeters cubed. So that is going to be my total volume. However, I also know that for gas laws, generally what I want to do is talk about the volume of, and I want units of liters, right? Well, a centimeter cubed is the same thing as a milliliter. So I can pretty easily convert this, and I can just say 17.9 liters. Now, realistically, I would be willing to bet most of your structures are smaller than this, but it's just an example problem, right? So that is the volume that I can now use. Ultimately, what we're going to get to is that's the volume of CO2 gas that I want to produce in this lab. So to continue on with our practice calculations, we need to write the balanced chemical equation for the reaction between vinegar and baking soda. Good news is it gave us all of that information back on this outline sheet, right? Baking soda reacts with acetic acid to form carbon dioxide, sodium acetate, and water. Okay, so I'll pause the video and I'll kind of bring all of that information over. Okay, so if you bring that equation over, you're going to have your sodium bicarbonate. So in this case, that is going to be your baking soda, which is going to be a solid. Acetic acid, which we use vinegar, which isn't pure acetic acid, right? It's really about 5% acetic acid, which is going to factor into our calculations later. Those things, when mixed, are going to produce sodium acetate, which will be aqueous. You're going to produce extra water. And then this is really our focus of we need to produce, in this example, 17.9 liters of CO2. That's going to be the goal, so we can make sure that the CO2 fills our entire vessel. So to do all this, what equation are we going to be using? We are going to be using the ideal gas law to solve all of this, which is also known as your Pivnert, PV equals nRT equation. And then we can fill in this information, which also came back from our outline, because our outline gave us all of this information here that our average room temperature in school, or maybe even in your house, about 23.0 degrees Celsius, pressure of 730 millimeters of mercury. So if we bring that information in, pressure 730.0 millimeters of mercury, volume is ours from above, which in this case was 17.9 liters. Moles we actually don't necessarily know yet. Our R value, we can go back and look up what our R values are, and then our temperature that was given to us was 23.0 degrees Celsius, but we also know that needs to be in Kelvin, so we're going to add 273. Therefore, we're going to find that this is equal to 296 Kelvin. Sorry, doing this, I realize we don't have the R values on there because you can find them in your notes and stuff, but the R value when we're talking millimeters of mercury is 62.4. So we can use that value. So then if I use our ideal gas law, and then we rearrange it to solve for the moles of CO2, right? Because that's what we're trying to work backwards to. We can plug in our pressure, our volumes, and all of that information. And we would find that we need 0.70, looks like I'll be working with 3 sig figs, so 0.707 moles of CO2. And again, we're working backwards to know exactly how much baking soda and exactly how much vinegar will I use. So it's important to note that going back to our equation, luckily these are all 1-to-1-to-1 ratios, so I can use that information to solve for my grams of baking soda. So then what I can do is I can take those moles of CO2. For every 1 mole of CO2 is a mole of baking soda, sodium bicarbonate. And then I know that the molar mass of that by adding up a sodium, a hydrogen, a carbon, and 3 oxygen is 84.01. And so if I plug that in, I find that my teacher will give me 59.4 grams of sodium carbonate, also known as baking soda. Let's go through and do the calculation then to find out how much vinegar we would get to mix with that. So doing that same process for moles of CO2, but working back to my acetic acid, I would find that acetic acid has a molar mass of 60.06. I would find that I'm going to need 42.5 grams of acetic acid, but we have to be careful. Acetic acid is not the same as vinegar. So the last thing that we have to do here is we're going to have to take, is acetic acid is only 5% of vinegar, right? So of all of the vinegar that you use, only 5% of it is actually acetic acid. So now what we need to do on this next step is we just need to remember that for every 1 gram is 1 milliliter. Convert grams of vinegar into liters of vinegar. Is vinegar pure acetic acid? The answer is no. And so ultimately what you're going to have to do is we got to take that answer multiplied by 20, right? Because for every 20 grams that you use, only one of it is acetic acid. So what we have to do back here is we're going to have to take this answer and multiply by 20. And therefore, we find that you would need about 850 milliliters of actual vinegar. So now what your teacher will give you when you do this lab is they would be giving you 59.4 grams of baking soda and 850 milliliters of vinegar. So this data is all based on this practice calculation, right? For this house and this data. When you build your own house, you're going to have to do all of your own calculations. So if you have any questions, make sure you can pause this video, you can rewind it, you can see all of the sample work here, slow it down. You can always ask your teacher or ask a classmate for help as well. So thank y'all.